Dear all, I'm going to take a problem on reflection and explain you how reflection works. So yesterday's session I discussed about two other transformations, that is reflection and shear. I told you those two are the not the basic transformations but the other kind of transformations. Now in this session I will be explaining. I'll take an object or a primitive and we'll see how we can reflect that with respect to the x-axis. So we'll see how reflection basically works. So reflection is also a type of transformation. Now we'll take an object and we'll see how we can perform a reflection. So this is the object which is being given, which we need to perform reflection with respect to the x-axis. So when you perform reflection with respect to the x-axis, so it should look like this. So the object should look like this after reflecting. So it is represented as A, B, C, D, E, F and G, and the points, they are represented in this way. A is given as 2.5, 6, B is given as 1, 3, C is given as 4, 3, D is given as 2, 3, E is 3, 3, F is 2, and G is 3, 1. So these are the coordinate values. So when you reflect it above the x-axis with respect to the x-axis, it is simple that if you just change the sign, you will be able to reflect it. But instead of just taking that direct way and just changing the signs, because if you see A, so A will obviously be 2.5, it will be -6. Only the change in the that is a sign happens here. But how do we solve it with respect to the matrix is what we need to see here. So in yesterday's discussion we already saw that with respect to the x-axis, when you're performing reflection, this is the transformation matrix 1 0 0 0 minus 1 0 0 0 1. Now we need to find x dash y dash, and here I am again considering a homogeneous coordinate system, not like our 2 cross 2. I am taking a homogeneous coordinate, what I discussed yesterday, into x y 1. So now how many points we need to find out here? This x dash y dash, we need to find it out for A dash, we need to find it for B dash, C dash, D dash, E dash, F dash and G dash. Now we'll see for A dash how we are applying. So you can take it as A dash of x comma y equals to 1 0 0 0 minus 1 0 0 0 1. So what are the points of A? A is 2.5 6 1. So if you multiply this in this way, you get 2.5, 0 into 2.5 minus plus minus 6 into 0 0 0 and 1. So you get this as the final matrix. So your x dash y dash 1 is this. So your A dash will become 2.5 minus 6. Are you getting this? So our A was 2.5 6, our A dash is 2.5 minus 6. And now the same thing, if you apply it Now you have an A dash. Now take B dash. B dash can be found out in the same way. 0, 0, 1 into. Now B is 1, 3. Homogeneous coordinate 1. So if you perform the multiplication, you get 1 minus 3, 1. So the B dash values become 1 comma minus 3. In the same way, if you take C, C is 4 comma 3. So C dash is equal to 1 0 0 0 minus 1 0 0 0 1. So this matrix is nothing but your reflection matrix. Okay, this is your 4 3 1, the coordinates of C. Multiply these two matrices, you get 4 minus 3 1. So in the same way, 4 comma minus 3. Now if I repeat the same for all the other points, this is what I get. I get A as A dash as this, B dash as 1 comma minus 3, C dash is 4 comma minus 3, D dash will be 2 comma minus 3, E dash is 3 comma minus 3, F dash is 2 comma minus 1, and G dash should be 3 comma minus 1. So this is what should be your final set of values, and if you plot this value, you should get the reflected image in this way. And this problem what I have shown is the reflection with respect to the x-axis. Are you getting this?